This is ordering, comparing, and rounding decimals. So the first thing we need to talk about is what decimals represent. And they represent part of a whole. For example, when you buy a pack of gum for 75 cents, you're left with only part of your dollar. So you can see in this example, the whole is $1. And then you take away 75 cents, part of that one whole, and you're left with 25% part of the whole. When a 0 is in the ones place, the decimal indicates a number less than 1. And then when a whole number is in the ones place, the decimal indicates a number greater than 1. To add to that, if we have a negative integer, for example, negative 2.6, we have a negative integer in the ones place, then we have a number that is a negative whole number and then a part of a number. You can create a decimal less than 1 here, which is pretty easy. Now you try creating a decimal less than 1 with each of these numbers. And here are some examples that are answers. Write all the decimals that are less than 1 in the left and all that are greater than 1 in the right. See if your answers match mine. Next, we are going to put the decimals in order from least to greatest. The easiest way to do that is to line them up on top of each other and compare each place value. For example, I'll do the first two. 0.02 and 0.18. I can tell that the zeros match in the ones place, but then when I get to the tenths place, I compare 0 and 1, and 1 is bigger. Therefore, 0.02 is smaller than 0.18. Another way to look at these numbers is since they all end in the same place value, the hundredths, I have 2 hundredths versus 18 hundredths. So 18 hundredths is bigger than 2 hundredths. Now go ahead and put these in order from least to greatest and then check your answer. Now check your answers. Next, we are going to talk about negative decimals. So let's think about where decimals lie on our number line. Where do you think they lie? If you think they lie in between the whole numbers and the opposite of the whole numbers, the integers, well, these are all integers, then you're correct. So right in here is a decimal, right in here is a decimal. Anywhere in between the lines that land on numbers here is going to be a decimal. Okay, so for example, let's say I wanted to find 2.5. That's a pretty easy decimal, so that would be about right there, 2.5. If I wanted to find 0.25, that's the same as a fourth, so that's about right here. What about if we were working with negative numbers? Where do you think negative 2.5 would be? Try graphing that. So that's about where negative 2.5 would be. What about negative 0.75? Negative 0.75. Try graphing negative 0.75. It'd be about right here. So you can see that just like with our whole numbers, once we start putting negatives in front of them, the larger the number looks, the smaller the value. So if I'm looking at negative 0.75 and negative 2.5, which one is going to be bigger? Negative 0.75 is actually bigger than negative 2.5. What about if I have negative 6.3 and negative 6.8? Which one of those is bigger? Negative 6.3 is bigger. So remember, what is bigger with a negative is always the opposite of what is bigger with a positive. So when the number looks bigger, it's actually smaller when you have a negative. So try putting the following problems in order. Do each one and then check it. So let's start with the first set here. Put those numbers in order and while you pause and then check the answer. Is this what you ended up with? Now try the next one. So how did you do on number 2? Keep in mind we're going from smallest to biggest, so negative 6.8 is our smaller number, and negative 6.0 is our bigger number. So just keep that in mind. Just like on our number line, when we go to the left, the numbers are the smaller numbers, and when we go to the right, the numbers are the bigger numbers. Right? Try number 3. How did you do? Again, negative 8.9 is the smallest number, and negative 8.0 is the largest number. Try number 4. Check your answer. Is this what you have? This was a hard one, wasn't it? Not only does it have both positive and negative numbers that you have to pay attention to, we are also dealing with going further out in our place value. So remember, the further out you go in your place value, the smaller the number becomes. With negatives, the smaller the number becomes. If it has a negative, it's actually a bigger value. And of course, with positives, the smaller the number, the smaller the number. So let's move on. This is a review of place value. You can see it goes all the way out to the millions on the whole number side, and over on the decimal side, it goes all the way out to the 10,000. I am going to say a number. See if you can write the number in the chart appropriately. I will say it twice. The first number is 23,456 and 15 hundredths. 20,000. Well, you know what? I just forgot the number. So I'm just going to write a number out. 20,000. I think I said something like this. 456 and 15 hundredths. So that's 20,456 and 15 hundredths. So you use the word and whenever you have a decimal. Actually, you also use the word and when you go, anytime you go from a whole number over to the partial number. So anytime you are finished talking about the whole number side and you're moving over to either a decimal or a fraction, say the word and. For example, 2 and a half. You say and when you're moving from the 2 to the 1/2. 3.5 is actually read 3 and 5/10. So how would you write 6 and 45 hundredths? 6 and 45 hundredths. When you're writing a decimal, whatever the last place value is that's mentioned, your number after the decimal should end there. So for example, I said 45 hundredths, so the 5 should end in the hundredths place. So try this. How about 6 and 5 hundredths? 6 and 5 hundredths. That should be 6 and, you put your 5 in the hundredths place value, so you're going to have a 0 in the tenths place value. 6 and 5 hundredths. Take a couple of minutes and see if you can match the correct numbers with the correct words that describe them, and then check and see if you're right. Here are the correct answers. How did you do? Are you getting a hang of it? Again, remember that the last word tells you the place value that the last number should end in. Let's try some more. Try these and then check back. How did this go? Again, the last digit mentioned should fall within the place value mentioned. Try these and then check back. Are you getting a hang of it? How did you do? We are going to skip past some of the activities that are classroom activities and move down to rounding. So when you round a decimal, or any number really, you always look at the number that comes after the digit that you're rounding to, and then you decide if the number should be rounded up to the next number or if it should stay the same. So for example, in this first number, 4 and 6,325 10,000, or 4.6325, you're being asked to round to the tenths. So what that means is you have to actually look at the hundreds and see if that number is a 4 below or a 5 or bigger. If it's a 4 below, then you leave the 6 to 6. If it's a 5 or above, then you change the 6 to a 7. You'll never drop the 6 down to a 5. It'll either be 6 or it will round up to a 7. So this one's 4.6 because the number after the tenths place, which is where we're rounding to, is a 3. Now if you look at the next number, we're going to, or the next example, we're going to round to the nearest hundredths. So we've underlined the 3 that's in the hundredths place, but we have to actually look in the thousands to determine whether that 3 should stay a 3 or go up to a 4. Since it's a 5, it's 5 or bigger, so it's going to go up to a 4. The reason that we use 5 or bigger to round is 5 is right in the middle. So you think of 5 as like a half. And so if something is halfway to the next number or more, we're going to go ahead and round it up. If it's not even halfway to the next number, then we round it down. Okay, so now let's do some examples. Try rounding each of these to the nearest tenths and then check. How did you do? Now try rounding each of these to the nearest hundredths. Check that. How did you do on these? Let's keep going. Try rounding here. There's some great problems. Ooh, look at that. Did you get these right? In case you weren't sure about the first one here, let me make sure you understand. We're rounding to the nearest tenth, which is this 9. The 9 before it is going to make that increase by 1, so that actually goes to a 10, but we can't put a 10 there. So we put a 0 and then carry a 1 to make that 9 round, the next 9 round up to a 10, and we can't put a 10 there, so we carry 1, and it makes the next 9 round up to a 10. So that's why we end up with 100. This concludes the end of our tape. Good luck.